Hey, what's up? Are you ready to get your face melted off by something cool that I just found out? Okay, so look at these little pictures of intersections right here, okay? Consider the graphs of a quadratic function and a linear function on the same set of axes. Notice that we could have the case where a parabola is being cut by a line and there are 2 points of intersection. A parabola is being crossed by a line at just one point. This is sometimes called the tangent. Remember when you guys learned about circles and they were like, there's a line tangent to the circle, right? It just touched the circle at one little point there. Or there could be a case where there's a parabola here and the line never crosses. We would say no points of intersection, no solutions. They're completely missing each other. Okay. You can not only use the discriminant to find the nature of solutions, right? If a parabola is going to cross the x-axis twice, one time, right, that was a bad drawing, one time or no times. You can also use it to determine the number of intersections. Yo, check this out. I thought the problem number one on the spiral, I was reading it and I'm like, oh man, this was miscategorized. Like there's no way you could solve this without calculus. But you can check it out. You can use the discriminant. All right, this is new and exciting. So if the graphs meet, the coordinates of the point of intersection of the graph can be found by solving the two equations simultaneously. We know that that just means setting the two equations equal to each other, right? Look at this super simple example here. I have a first parabola, x squared, and then I have a line, y equals x. I'm going to set them equal to each other to find the points of intersection. Sorry, I'm skipping ahead a step. Equals x. I would subtract an x from both sides. I would get x squared minus x equals 0. Factor out an x. Get my two solutions. Hooray. Okay, we already knew how to do this. However, check it out. You can use the discriminant, right? This is so cool. You can use the discriminant of this parabola here to find out how many times the line will cross the parabola. Nuts. Okay, so A is going to be 1, B is going to be -1, C is going to be 0. We have B squared minus 4AC. We have -1 squared minus 4 times 1 times 0. And then now I have 1 minus, this whole thing becomes 0. That's just 1. Okay, so it is a positive discriminant. Therefore, we know that it's going to have two solutions or two intersections. Okay, two intersections. Very cool. So look, check out this graph. I graphed it. I queued it up. Okay, look, we have two intersections of these two functions, the parabola and the line, and we use the discriminant to determine that. What? All right, let's see right here. We've got 2x plus k is a tangent to y equals 2x squared minus 3x plus 4. Find k. Okay, this is just like the spiral question, right? Think about it like this. I can set the two functions equal to one another in order to find the coordinates of intersection, right? So I've got, that was my shoe for the record, that noise. Okay, so now we have minus 2x. We have 2x squared minus 5x plus 4 minus k minus k minus k. All right, so I've got 2x squared minus 5x plus, and then I'm just going to group these together because it helps like underscore the idea that that is supposed to be the c or the constant, right? Okay, so now I know that this is a tangent too. And remember up top, we said that tangent is a fancy way of saying that it just touches once. What do you know about the nature of solutions to a parabola that just touches the x-axis once? Its discriminant is going to be 0. So just like that, the discriminant is going to be 0 in this instance here because this line and this parabola only cross one time. Very cool. Okay, so we have 2x squared minus 3x plus 4. Now you're in the way. Goodbye. Equals 2x plus k. We just did that. Now we're setting up the discriminant. Sorry. Okay, discriminant. B squared minus 4ac. Okay, so we have a equals 2, b equals -5, c c equals 4 minus k. Let's go ahead and plug that into our discriminant. We have negative 5 squared minus 4 times 2 times 4 minus k. What do we get here? 25 minus 8 times 4 minus k. 25 minus 32 plus 8k. Okay. And since it only has one point of intersection, we're going to set it equal to 0. And now we have 25 minus 32 is going to give me negative 7 plus 8k equals 0 plus 7 plus 7, 8k equals 7. Divide both sides by 8 and you get k equals 7/8. So the line y equals 2x plus 7 over 8 is supposed to be tangent to the graph of y equals 2x squared minus 3x plus 4. Let's go ahead and check and see. Oh my gosh, it is. Check it out. If you zoomed way in, oh my gosh, I didn't mean to move the line. But if you zoomed way in, close enough. If you zoomed way in, you would see that they are, in fact, tangents. Other than the fact that I moved this guy right here on accident with my hands, but they are tangents. Let's go ahead and go back in and fix it. Give me this graph. 2x. What do I do on here? Sorry, you are being annoying. It's not a relation, it's a function, whatever. Okay. So now, it's all weird, but yes, they are tangents to one another. You saw it in the beginning, okay? All right, so you can use the discriminant to tell you about points of intersection with a parabola and a line as well. Very cool. Let's graph it again. I just want you to know. Okay? It would be 2x squared minus 3x plus 4. 2x squared minus 3x plus 4. And then the new graph is going to be 2x plus 7 over 8. Yeah, there we go. Menu zoom. Yeah. Check it out. Woohoo.